Okay, we're going to talk about transformations. So let's say that we have f of x and it has the point x comma y. We could do several transformations on f of x. So let's say we could do these things. We could have an a as a coefficient. We could have a b inside, a c with the x as a plus minus, and we could have a d as a transformation. This means that the new point would have coordinates x divided by b. Okay, so this b changes the x value. The c also changes the x value. And then the a and the d affect the y. So a is a multiplier and d is a shift up. Okay, so what happens? So a is a vertical stretch. So that is why it got multiplied by y. Okay, it stretches your y up. And d is a vertical shift. So it would move your points up or down. So therefore, if it's plus d, it will shift up d amount. B is a horizontal compression. So you would divide by b. So if this is 2, then your x value would actually be half of its original. And c is a horizontal shift, which would move left and right. And this one is opposite. See how this says a plus c and this is a minus c. So if this says plus 3, you're actually moving 3 left. Okay, versus if you see a plus d, you're moving the same regards that you see it. So you did a little bit of this in grade 11 when you talked about quadratic equations. So you might have seen an example like this. Okay, so this would have a vertex of 4, 6. So in other words, it moved right 4, and it would have moved up 6. And then this 3 as a multiplier, right, makes those vertical points stretch instead of doing. So here's our vertex. It already moved 4 and up 6. And then our points get stretched out. Instead of moving 1 over, 1 up, I'm going to now go 3 up from there. So it's stretching out those y value points. Okay? Okay, so let's make a chart here. Transformation. We'll describe it and how it would affect the point. Okay, let's use f of x, and let's say that f of x has the point 4, 5. We'll just say that for all this. Okay. So when you have an a f of x, it's a vertical stretch by factor of whatever a is. And how it affects is that it changes your y value. It makes your y's go up at a faster rate or a slower rate. So let's say that we are going to go to f of x. It would have the point 4, 10 instead of 5. Okay, f of bx. So now this is affecting the x value. So this is a horizontal compression by a factor of b. So how it affects is that it divides the x value. So let's say that I have f of 2x would now reach the height of 5 when x is 2 instead of 4. Okay, it squishes it in. Okay, f of x plus c. So horizontal shift. And again, it can go left or right according to the c value. And so it would go in opposite manner of what you would see. So if I had f of x plus 3, then that would move left 3. So you would now have the point 1, 5 instead of 4, 5. F of x plus d is a vertical shift. So that would go up or down. And this is as you see. So if I do f of x plus 3, then I would have the point 4, 8, because I would add 3 to 5. Okay, now what if we do this? Okay, so when we do this, we are essentially having a -1 for our a, which is our vertical points. So we're changing the negative on the y. So when we change our y values, that makes it flip over the x-axis. So a reflection, and we're actually going to call that a vertical reflection, and then it would be over x-axis. So in our case, our point would change to 4, -5. And so what if we put a negative in front of our x like that? Then that changes our x value to be negative. So then it would be a horizontal reflection, and then that would be over the y-axis. So f of r's would become -4 or 5. Okay, what if we have f of -1 of x? So this is called an inverse function. And what happens is it reflects over the line y equals x. So that diagonal line. Okay, so that would be a reflection. And what happens is that the x and the y change. So in our case, our new point would be 5, 4. Okay, and what if we have the absolute value of x? So when we have absolute value, if you take the absolute value of a positive number, it stays positive. And if you have an absolute of a negative number, then those change to positive. So points that are above the x-axis stay, and points below the x-axis, so negative y values, they reflect above. So this would be, and on ours actually wouldn't even change because I gave you the point 4, 5, and 5 is already a positive, so it doesn't need to change. And then our last example you might see is 1 over f of x, and this is a reciprocal, and we did a little bit of this in grade 11. So you're changing the point by taking the reciprocal of the y value. So our point would have the new point 4, 1/5. And remember when we did this, we kind of had 3 special things going on. It was an asymptote, where y was 0, and invariant points where y was plus or minus 1, because when you reciprocated those, they stayed at 1 or negative 1. And then patterns that if it was a lower, then it was higher, right? And the lower and the higher numbers were lower. The opposite relationship.